everyone, myself Dr.N.Ram Babu, working as an assistant professor in the Department of Electrical and Electronics Engineering at the University-Surampalem. In this session, we are going to discuss about transient responses of series RL circuit with AC excitation. So, in the previous class sessions, we have discussed about DC circuits. Now, we are going to the AC circuits. That means the supply voltage is replaced with the AC waveform, that is sinusoidal waveform, and we are going to look at the circuits, how the transients are going to and how the transients are going to come in the circuit. Okay. So, at the end of the session, the students are able to analyze the transient behavior of electrical RL networks for AC excitations. Okay. Now, as we have stated that we are dealing with series RL circuit with AC transients. So, we know that series RL in the sense resistance is in series with inductor. So, here it is R and here it is L inductor, and a supply voltage of E, where E is Vm sin omega t. Vm is the maximum voltage and omega is the frequency, nothing but omega is equal to 2 times of pi into f, where pi is 22/7, f is the frequency. Okay. And at time t equal to 0, the switch S1 is closed and the current I is flowing through the circuit. Okay. Now, we are going to derive the equations of current I of t. Okay. And we are solving it by using the Laplace transform method. So, in the previous DC transients, we have discussed it with differential equation method. Now, we are we can apply the differential equation method for this circuits also, but we are applying Laplace transform method because which is very easy to attain the equation and all the things. So, now I am writing before going to start our session. Here see, here we have an inductor, where inductor does not allow sudden change in current. Therefore, the initial value condition will be I of 0 plus is equal to I of 0 minus is equal to 0. The reason is the inductor here does not allow any sudden change in current. So, for that purpose, this will be the initial value condition. Now, I am applying KVL for this circuit. So, see here, E is here, where E is applied. E is equal to I of t into R plus L into di by dt. Okay. Where I of t is the series current flowing through the circuit and R is the resistance, L is the inductance, di of t by dt is differential rate of change of current, and E is the supply voltage. I have stated that E is Vm sin omega t. Vm sin omega t. That is equal to I of t into R plus L into di of t by dt. Okay. Now, I am applying the Laplace transform method so that I will be attaining the whole sum in the terms of I of s. So, see here, if I apply Laplace transform for sin omega t, it will be omega by s square plus omega square. Okay, for sin omega t, it will be omega by s square plus omega square, where I of t will be I of s and R is the constant, so it will be as it is, and L we are supposed to keep the constant, and di by dt is s into I of s minus I of 0. Okay, but here see, I of 0 is 0, so this term will be 0. Now, if I simplify this one further, it will be I of s, okay, R plus s into L. Okay. Now, if I write this I of s expression alone, I of s will be I of s is equal to, I am taking this R plus SL this side, Vm into omega L by s square plus omega square into 1 divided by R plus SL, that is I of s is equal to Vm omega L divided by s square plus omega square into 1 by R plus SL. Okay. Now, here I am taking this L constant so that it will be in the form of s plus a or s minus a. Okay. Now, see here, I of s is equal to Vm into omega L whole divided by L, because I am taking this L outside, and it will be S square plus omega square into S plus R by L. Here this L gets cancelled, then it will be Vm into omega by S square plus omega square and S plus R by L. Now here I want to solve this equation in terms of I of t. So therefore here it is a second order differential equation. So for this I am trying to reduce into first order. Okay, now see here I am writing it. Vm into omega by S plus j omega into S minus j omega into S plus R by L. If I multiply this two part, it will be S square plus omega square. Now see here, it will be in the form of A by S plus A by S plus B into something, K by S plus A into S plus B into S plus C. Now here what I am doing is, now I am rewriting the entire equation in terms of K by S plus A plus S plus B plus S plus C. Okay. So here if you observe this one and this one is both are same. Now see, I am splitting this part. Vm omega by L whole divided by S plus j omega, S minus j omega, S plus R by L. So now here what I am doing is K1 by S plus j omega plus K2 by S minus j omega plus K3 by S plus R by L. Okay. Now I have done this part. Now I am doing the variable separable method to solve the values of K1, K2 and K3. See here, this expression I got it. Here it is K3. Okay. Now I am simplifying this one further. So see here how I am simplifying it. K1 into S plus j omega into S minus j omega plus K2 into S plus R by L into S minus j omega plus K3 into S plus R by L into S plus j omega, which is equal to this side C, Vm into omega by L. So denominator part will be cancelled on both the sides. Okay. Now here I am doing, now I am multiplying this one further. Okay. So it will be K1 into S square plus j omega S minus j omega S minus of minus plus and plus j into j square. So it will be plus into minus, it is minus and I square is minus 1. Okay. Plus K2 into S square plus S into R by L minus S into j omega minus j omega into R by L. Now leftover part is K3. K3 into S square plus S into R by L plus S into j omega plus R by L into j omega is equal to Vm into omega by L. So if you observe this one, means this two gets cancelled. Okay. Now, so if I take the S square terms outside, it will be K1, from this one it is K1, and from this one it is K2, and from this one it is K3, K1 plus K2 plus K3 equal to 0. And if I am taking the S terms outside, here in this expression see, K2 into R by L, next one, minus K2 into j omega, okay, and this part, this one, plus K3 into R by L plus this one k3 into j omega is equal to 0 because no s square terms on the other side. Next, if I am taking the constants, see this one k1 into omega square plus in this part it is minus k2 into j omega r by L plus k3 into r by L j omega equal to 0. So, see here, this one I am keeping it as equation 1, this one I am keeping it as equation 2, this one I am keeping it as 3, and we know that how to solve the three unknown terms in an equation. That means k1, k2, k3, k1, k2, k3. Now see, k1 plus k2 equal to minus k3. So, you can substitute any one of the values in the 2 and 3 equations and simplify it and solve it. Okay. After solving the equations, I am writing out the final expressions of k1 and k2, k3. Okay. Now, after solving all the things, I am writing the k1 equation part. K1 is equal to Vm omega L by omega square L square plus R square, and whereas K2 is minus Vm omega L by omega square L square plus R square, and K3 is Vm into omega R by omega square L square plus R square. Now, I need to substitute this all values, this K1, K2, K3 values in this expression, and also here let me substitute it and you will get an idea. See, Vm omega L by S plus R by L into this one is K1 and this one is K3. Okay, here it will be omega R by omega square L square plus R square. So, the value of K2 is Vm omega L by omega square L square plus R square into 1 by S plus J omega, and whereas K3 is minus Vm omega L by omega square L square plus R square into 1 minus 1 by S minus J omega. Now, see here, this is the expression for I of S. Okay. Now, what I am doing is, I am taking this part inside. How I am taking, I will show you the thing. See here. We all know that 4 we can write it as root 4 into root 4, right? That means root 4 is equal to root 2 times of 4 into 4, that is 2 into 2, that is equal to 4. Now, I am doing this, converting this part into that term. Okay. Therefore, Vm omega L divided by S plus R by L into omega R by omega square L square plus R square. Okay. Omega square L square plus R square. If I multiply both things, I will be getting this common constant. And here, Vm omega L by omega square L square plus R square, omega square L square plus R square into 1 by S plus J omega, and minus Vm omega L divided by omega square L square plus R square, square root of omega square L square plus R square into 1 by S minus J omega. Now, I have written up to this part, and now I am taking the RL circuit triangle. Okay, just remember these equations. Now, I am taking the RL circuit equations and I am substituting that part. I am erasing the upmost part so that we will getting some clear idea over here. As per the triangle, this is resistance R and this is omega L and this is an angle phi and this is Z. Impedance angle Z is equal to R plus J omega L, whereas sin theta is sin theta, opposite side, omega L by Z means square root of omega square L square plus R square, and whereas cos theta is adjacent side, R by omega square L square plus R square. Now I am converting this part, see here, omega L, this part, omega L by omega square L square plus R square, it will be in the form of sin theta, and this part also sin theta, and where is R? R is here, okay, it is in the form of cos theta, okay. Like that, if I substitute this triangular equations in the following equation, we will be getting the final expression as R minus j omega by this one, and this will be in the form of like this, and from the impedance triangle phi is tan inverse of omega L by R. So after substituting all the equations, okay, after substituting, that means after converting this entire equation in the forms of sin and cos, okay, and we are multiplying this one and applying Laplace transformation, the whole equation is in the form of I of t is Vm by R square plus omega L whole square into e power of minus R by L into t sin theta plus sin of omega t minus phi, where this phi is this impedance angle, okay, impedance angle, okay. And if, for example, if we take a phase difference angle of theta, okay, so in our problem we have taken E is equal to Vm sin omega t only. Phase difference we haven't considered. If we consider the phase difference, that means it will be modified as Vm sin of omega t plus theta. If we consider this equation, then this equation is modified in the form of, here phi is there na, it will be in the form of theta minus phi, and this one also phi theta minus phi, okay, because this is the phase angle and this phi is impedance angle. Now let us look into a numerical so that we will be having clear idea. See here, a series RL circuit as shown in the below has figure sinusoid expression E is equal to 100 sin 500 t plus 30. That means Em is 100, omega t is 500. That means omega is 500 t. Omega is 2 pi f, that is equal to 500. From this we can calculate the value of f. After closing the time at t switch, that means at time t equal to 0, the switch is closed. Assuming that inductor is initially relaxed condition, that means I of 0 plus is equal to I of 0 minus is equal to 0, here it is saying. And the circuit elements are R is equal to 5 and L is equal to 0.0100. Now they are asking us to find out the expression of current, okay. What are the expression which we derived earlier? This is the expression, and we can directly substitute it. Em is 100, okay, and R is 5 ohms, omega into L, where omega is 500. So 500 into 0.01, substitute it, omega t, 500 t, the value of theta is 30. This is phi, phi is tan inverse omega L by R, that means phi is equal to tan inverse of omega L. Omega is 500, L is 0.01 divided by R, 5 ones, 500s, 100 into 0.01, it will be tan 1. Tan 1 in the sense phi is equal to 45, okay, and theta is 30 degrees. Therefore, the value of theta is, this one complete value is minus 15 degrees, okay, and this one is also minus 15 degrees. The power of R by L into t, substitute it and directly we will be getting the answer. Now let us look into the second example. Here also it is a direct problem, but the values of resistance is 50 and 0.2 ohm. That means previously it is 5 and this is 0.01, now it is 0.2 Henry, and supply voltage is also changed. VE is 150, omega is 50. Now this one also substitute it, calculate the values and we will be getting directly the answer. So while coming to the summary, here we have done the calculation part, that means derivation of current with the help of Laplace transforms, okay, with the help of Laplace transforms we have done the calculation part and we get the phase and lag lead conditions. And also here we have considered a series RL circuit where inductor causes energy storage and releasing. The power factor also we have measured it, and also the impedance angle triangle, that is R and phi, XL and Z. That means the impedance triangle concepts also we have studied from this study. Okay, thank you.